Hey, Math 206, it's Dr. McGathy, and we're talking about the Pythagorean Theorem now, which relates the sides of the right triangle together. So first we need to know some vocab. If you have a right triangle, that means a triangle with a 90-degree angle. We call the side that's opposite the 90-degree angle, we call that the hypotenuse, and that's the longest side. And then the two other sides you call the legs. And usually we label them with the side lengths A, B, and C. All right, so what the Pythagorean theorem says is that the square of the two legs, a squared and b squared, they sum together to equal exactly the square of the hypotenuse. And I have a video here that shows a visual of what that looks like. And let me just go through the proof of that really quickly. So imagine that you have a right triangle with side lengths A and B for the legs and C for the hypotenuse. This is two different squares that have side length A plus B. So this is a square with side A plus B, and this is also a square with sides A plus B. Okay. All right. So again, A plus B is the side length, A plus B is the side length. So these are two squares with exactly the same area, but they're arranged a little bit differently. So this one is arranged so that the triangles with side lengths A and B are stacked in the corners, right? And that the square with side length C is exactly in the middle here, right? And so here you can imagine that the area of the large square can be broken down into the area of the four triangles plus the area of the middle square. So here the area of the large square can be thought of as four groups of the area of one of these triangles, which is 1/2 times the base times the height, so times A times B. And the area of the middle square, where the middle square just has side length C, so that area would be C squared. So again, this, if I simplify, 4 times 1/2 is 2, 2AB plus C squared is the area of this large square. Now, let's take a look at the arrangement here. Again, same square, same exact area. You have 4 of these triangles. So again, the area of the 4 triangles, and then plus the area of the small square plus the area of this larger square, or the green square and the yellow square if you like. And again, these two squares have exactly the same area, so these two areas should be the same. So the area of these 4 triangles, again, I have 4 groups of 1/2 base times the height, 1/2 AB. The smaller square has side length A, so the area is A squared. And this larger square has side length B, so its area is B squared. If I simplify that, you get 2AB plus A squared plus B squared, and that should be exactly equal to 2AB plus C squared. Subtract 2AB from both sides, and we get exactly the Pythagorean theorem. A squared plus B squared has got to be equal to C squared. And they think that Pythagoras, who was a Greek mathematician, that this was probably the proof that he came up with. And then the next video that you'll see is a visual of the sum of the areas of the two squares, A squared plus B squared. So again, this is a square with side length A, and here's a square with side length B, being exactly equal to the square of side length C. So you'll see that as a visual. Now that we understand why the Pythagorean theorem is true, let's go ahead and use it to solve some problems. The size of a rectangular television screen is given as the length of the diagonal. So you might have seen that if you go to purchase a television and it's like a 24-inch screen, they are telling you this length right here, the diagonal. Okay, so in our example, they're telling us the length of the screen is 24 inches and the width is 18 inches. What is the size of the TV, or what's the diagonal length? So let me call the diagonal D, I guess. And this is a right triangle because I was dealing with a rectangle to begin with. So I know if this is A, this is B, this is C, I know that 24 squared plus 18 squared should be equal to the hypotenuse squared, right? Where D equals the diagonal length in inches. All right, so we can just go ahead and calculate that. 24 squared is 576 plus 18 squared is 324. And that should be equal to D squared. So if I add those two together, you get 900 equals D squared. Now, to find what D is, you'll have to take the square root of both sides and then only take the positive square root. So D should be equal to the square root of 900, which is 30. So the diagonal is 30 and my units were inches. All right, let's do one more example. Suppose you have a pole, and you call it BD, is 28 feet high, and it's perpendicular to the ground. All right, let me draw that in. It's perpendicular to the ground. And you have two wires, BC and BA, 35 feet long, attached to the top of the pole. So they both have that common vertex B. So I should make this the top B, D the bottom here. And they're attached to the top of the pole and to stakes A and C on the ground. So it sort of looks like this. Here's A, here's C, and these, so this is 28 feet, and each one of these is 35 feet. Points A, D, and C are collinear. They lie in a straight line. How far apart are A and C from each other? That's what I'm trying to figure out. All right, so first, let me notice that I have these right triangles here. Let me first solve for the length from D to C. And if I know that length, I could double it to find the length from A to C, right? So let's let X be the distance DC, and I should use the units that I'm using in the problem. So everything was in feet, so I should say it's in feet, right? All right, so then using the properties of right triangles by the Pythagorean theorem, I know that 28 squared plus x squared is equal to the hypotenuse squared. Hypotenuse is 35, equals 35 squared. So doing those calculations, 28 squared gives me 784, and 35 squared gives me 1,225. Let me subtract 784 from both sides to find what x squared is. So that's 441. And then we'll have to take the square root of both sides. Square root of 441 happens to be 21. So this length here is 21 feet. So then I double it, and AC should be equal to 42 feet.